Greetings, calculus fans. All right, so this is worksheet 2, and let's do the key. All right, so this is basically just finding the derivative of each function. So we're going to do dy dx. Okay, and you could use, make sure you use your product rule, your quotient rule, whatever, but, we can use this 1 over x. I can write this as x to the minus 1 if I want. Right? That makes it maybe a little bit easier because I kind of like using the power rule as opposed to using the quotient rule, though it doesn't matter. If I use that, I get negative 1 x to the negative 2. And then sometimes people use the product rule with this, and don't do that because it's negative 3 times the derivative of that, of sine of x, which is cosine of x. So you have a final answer of negative 1 over x squared minus 3 cosine of x. Okay, it's pretty easy. Okay, this one is pretty easy too. Let's just do the quotient rule for the second part. The first part's easy, right? So f prime of x is equal to 3x squared minus 3 minus, well, it's the bottom. Remember, always do, it's the bottom times the derivative of the top. Don't do the reverse and say the top times the derivative of the bottom. Just remember, your corporate ladder, you always start from the bottom and you work your way up. Okay, so it's bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is 4x cubed, all over the bottom squared. So x to the 8th, right? Okay, so let's just simplify that a little bit. So 3x squared minus 3 plus, write two negatives, plus 8 over x to the 5th. Okay, that's not bad. Okay, this next problem, math fans, is you could use the quotient rule here, but why not split it up and make it easier? So I'm going to rewrite this as, well, I'll show my work here, x cubed over x squared minus 3x squared over x squared plus 4 over x squared. So again, I haven't even taken the derivative yet. I just get x minus 3 plus 4 over x squared. And now I'll take the derivative. Okay, so y prime is equal to, derivative of x is 1. Derivative of negative 3 is 0, so I'm not even going to put anything there. And then again, here I can use the quotient rule. Bottom times derivative of the top, which is 0, minus the top times derivative of the bottom, all over the bottom squared. So I get y prime is equal to 1 minus 8 over x cubed. Okay, it's not too bad. All right, next one. Really can't simplify. If we could, we would simplify it, but we really can't simplify this guy. Nothing to factor the bottom two to simplify it, so we're just going to use quotient rule here. So y prime, it's the bottom times derivative of the top. Derivative of the top is just 1. Do you guys agree with that? Minus the top times derivative of the bottom, which is 2x plus 2, all over the bottom squared. Okay, the bottom we're not really going to do anything with it. Can't really simplify that. The top, I can definitely get rid of some of these things here. Simplify, well, obviously, this first one you just multiply by 1, it's no problem, right? So y prime is equal to x squared plus 2x plus 2, and this guy here I just FOIL, so it's minus, and we'll put this in minus 2x squared plus 4x plus 2, right? So when I FOIL that out, all over x squared plus 2x plus 2 squared. And then if I distribute that negative and I combine like terms, I wind up getting negative x squared minus 2x all over x squared plus 2x plus 2 squared. Okay, that's your answer. Yeah, that's pretty easy. Okay, again, number 5, I think I would split that up. I could use a quotient rule, but I think I'm going to rewrite this as f of x. 2x squared over x is just 2x minus 3 plus 1 over x. A lot easier to deal with that. So f prime of x is equal to 2. Again, that's 0. You can use the quotient rule. Bottom times derivative of the top, which is 0, minus the top times derivative of the bottom, so minus 1 all over the bottom squared. And that's it. my answer. Okay, that's actually pretty mellow. Next one, yeah, it's pretty easy. F prime of x equals 4/5, just using the power rule. And you subtract 1 from that, so you get to the negative 1/5. Okay, and so we're going to have f prime of x equals 4 over 5x to the 1/5 power. Okay, pretty easy. Okay, we're going to use the product rule here. So f prime of x, the first times the derivative of the second, plus the second times the derivative of the first. And so we just kind of simplify a little bit. We get x squared cosine of x. It's usually good to put that 2x in front, right? That's pretty standard procedure. Sine of x. Okay, that's it. This next one, now, next chapter, math fans, or chapter 3b, you're going to actually learn how to take the derivative directly, okay, using something called the chain rule. Right now we don't know the chain rule, so you're going to actually rewrite this, and you're going to FOIL this out. Okay, so if I FOIL that out, I get x to the 6th minus 4x cubed plus 4. And now I take the derivative. So it's 6x to the 5th minus 12x squared. Okay. This next one, use the quotient rule. So bottom times derivative of the top. So t, it's actually t times, that's right, show my work here, negative sine of t. So bottom times derivative of the top minus the top times derivative of the bottom, which is just 1, all over the bottom squared. So you get y prime is equal to negative t sine of t minus cosine of t all over t squared. Now you could split it up, but this is fine. You could write, so you can cancel out the t's on the m1 and still have a t squared for the other one, but that works fine. Okay, number 10. Again, you can use the product rule. So y prime is equal to the first times derivative of the second plus the second times derivative of the first. So you get y prime is equal to negative sine squared of x plus cosine squared of x. Now, I'm going to rewrite this because maybe you can recognize what this is. Cosine squared of x minus sine squared of x. Okay, you guys really kind of should remember some of these identities. This is one of your double angle identities. In fact, this is for cosine of 2x. So that's exactly what it is. Y prime is equal to cosine of 2x. Okay? And, obviously if it was, written as 2 cosine squared of x minus 1 or 1 minus 2 sine squared of x, that would, all three of those is, or are cosine of 2x. Same thing if it was sine of x cosine of x, that would be sine of 2x. All right? Not bad. Okay, let's keep going here. F prime of x equals derivative of 1 is 0, so that's easy. I would actually write this as x to the 1/2 and then use the power rule. So it's 1/2 x to the negative 1/2. So f prime of x is equal to 1 over 2x to the 1/2. Okay. 12, we're going to use the product rule. So y prime, the first, times derivative of the second, secant squared of x, plus the second, times derivative of the first. And let's just simplify it a little bit. Just, again, get rid of the parentheses. Plus 2x tangent of x. Okay, not too bad. Okay, let's keep going here. Cruising right along. Number 13. Again, it's a lot easier if you write it with rational exponents. So x to the 1/3 power plus x to the 1/5 power. And then apply the power rule. So you get 1/3 x to the negative 2/3 power plus 1/5 x to the negative 4/5 power. Okay, and you really should not have negative exponents. You really should have positive exponents. So we're going to say f prime of x equals 1 over 3x to the 2/3 plus 1 over 5x to the 4/5. Okay, not too bad. This next one, remember, if you can simplify it beforehand, do so. Okay? I mean, you could use the product rule here and multiply it out, but I know that tangent of x and times cotangent, isn't cotangent 1 over tangent of x? Oh, look at that. So really, my equation is y equals 1. What's the derivative? What's y prime? 0. Okay, a lot easier to do it that way than, I mean, you could have done product rule and it would have all worked out for you really nicely. You'd have had some nice friendly identities and, you'd be able to cancel things out. But it's a lot easier. All right, let's use quotient rule here. Bottom times derivative of the top. So x times derivative of secant x is secant x tangent of x minus the top times derivative of the bottom. So just minus secant of x all over x squared. Okay, not really more you can do with this one. I mean, does it make any sense to factor out a secant of x? Probably not, because there's nothing really to cancel from the bottom. So that's your answer. Okay, number 16, f prime of x, derivative of cosecant of x. So it's negative. Remember, you can just kind of factor the negative out. That's cool. It's kind of like, say, -1. And then derivative of cosecant. Anything with co is a negative. So it's negative cosecant of x, cotangent of x. And then derivative of sine is cosine, so minus cosine of x. So simplify that a little bit. We get cosecant of x, cotangent of x, minus cosine of x. Okay, pretty easy. This one, just a little bit more work here. Using product rule for this guy and for this guy. Okay, so first times derivative of the second plus the second times derivative of the first. And then, guys, you don't need to multiply that by 2. It's just plus, and then you can put a 2 on the outside of that if you want. Okay, and then use the product rule. But make sure the 2 is multiplied by everything. All right, so it's the first times derivative of the second times negative sine of x plus the second times derivative of the first, which is just 1. Okay, not 2. Oops, that should be a bracket. Not 2 because I put the 2 on the outside here already. So I wind up getting y prime is equal to x squared cosine of x plus 2x sine of x. And then if I multiply that out, I get, and like this guy right here, I get minus 2x sine of x, and then plus 2 cosine of x. Okay, so just, it's a little complicated here. And these guys cancel, right? It's kind of nice. So I get y prime is equal to x squared cosine of x plus 2 cosine of x. Okay? Half the battle, calculus is actually pretty easy. Half the battle, or most of the battle, is actually the algebra. Okay, so here's the next one. I would definitely write it as a rational exponent. So I'm going to write this as x to the negative 2/3 power. It's a lot easier to take the derivative of that. So then I say f prime of x equals negative 2/3 x, and then you're subtracting 3/3, so it's minus 5/3 power. So you get f prime of x equals negative 2 over 3x to the positive 5/3. Okay, pretty mellow. The same one here, we're going to learn it later on that you can use the, well, we're going to just use product rule here, right? Okay, so let's do that. It's the first. So let me leave a little bit of room here. G prime of x. So the first times derivative of the second, which is 2x plus 3, plus the second times derivative of the first, which is 4x. Okay, and let's kind of FOIL some stuff out here. So g prime of x, I get 4x cubed plus 6x squared minus 6x minus 9 plus 4x cubed plus 12x squared minus 16x. So g prime of x equals 8x cubed plus 18x squared minus 22x minus 9. Okay, just again, got to be careful with your algebra. Okay, the next three problems are finding the second derivative. So obviously you got to find the first derivative first. So I do dy dx. dy dx is kind of messy there. dy dx is equal to, we're going to use the, of course, just our power rule. It's 3, so I'll show my work here. 3 halves times 4x to the, I'm subtracting 1, so to the 1/2. Okay, that's the first derivative. So let's simplify that. That's just going to be a 1 and a 2. So that's just going to be 6x to the 1/2. And then the second derivative, that's pretty easy. Bring 1/2 comes to the front, times 6, and then x to the negative 1/2. So that's equal to 3 over x to the 1/2. Okay, that was pretty easy. This one, just a little bit more work. We're going to use the quotient rule. So y prime, the bottom, times the derivative of the top, which is 1, minus the top, times the derivative of the bottom, which is also 1, all over the bottom squared. So I simplify that, and I get x minus 1 minus x over x minus 1 squared. Okay, then I can simplify that. X minus x goes away, and I just have negative 1 over x minus 1 squared. All right, now this is the deal, math fans. We're going to use the quotient rule here. All right, so y double prime equals, so it's bottom times the root of the top, which is 0, minus the top, so minus, and then it's negative 1, times the root of the bottom, which is 2, parentheses x minus 1, all over the bottom squared. So it's to the 4th power, right? And I'm kind of running out of room here, so I'm just going to write it up here. And I wind up getting, of course, that cancels out, and we have a positive value, so it's positive 2 parentheses x minus 1 all over x minus 1 to the 4th. So don't you agree that cancels out and that becomes a 3? So I really have 2 over x minus 1 to the 3rd power. Okay. The next one, this is a good example of, you don't really need to use product rule here, math fans. Just the 3 just kind of comes out, right? So it's just going to be y prime is equal to 3. What's the derivative of sine of x? Cosine of x. There we go. That's the first derivative. Second derivative is 3 times what's cosine of x? Negative sine of x. So you wind up getting negative 3 sine of x. All right, not too bad. Okay, let's move on to 23. Find the equation of the tangent line to the graph of the given function as at the indicated value of x. All right, so again, to find the equation of the tangent line, right, we need to find the slope. So we're going to do f prime of x. And again, if you want to use quotient rule, that's cool. Bottom times root of the top, 0 minus top times root of the bottom, which is 1 all over the bottom squared. Yeah, it's minus the top times root of the bottom. Okay. And then let's just find the equation. Of course, this is the equation, or this is to find the slope, m, right, of the tangent line. And so we're going to plug that value of x into here to actually find the slope. So f prime of 1, well, it's equal to negative 1 over 1 squared, which is negative 1. So that's my slope. That's m. And how do you find, you need to put in point slope form, don't you need an x and a y value? Okay, well, we have an x value. How do you find the y value? You plug it back into the original problem. Okay, so it's f of 1 is equal to 1 over 1, which is 1. So really, my coordinate is 1 comma 1. So the equation in point slope form is really easy. It's y minus 1 equals negative 1 times x minus 1. Okay, it's kind of got a lot of negative ones and ones in here, right? But that's it. That's point slope form. And what if I asked you, just for that, what if I asked you what is the an equation of the normal line? Okay, well, wouldn't that just be y minus 1 is equal to, what's the reciprocal of negative 1? Opposite reciprocal. Well, it's just 1. So it's going to be x minus 1. Right? And then you wouldn't do it, but in this case here, it doesn't, sometimes just you add 1, so you actually get y equals x. Okay, but that's fine, the way it is. Okay, 24. Okay, same thing, we're taking the derivative. So y prime, that's going to be 4 times cosine of x minus 1. And so we're going to do y prime at 0. So it's going to be 4 cosine of 0 minus 1. Cosine of 0 is 1. So that's 4 minus 1 is 3. So that's your slope. Slope is 3. And at x equals 0, what's my y value? 4 times sine of 0 minus 0. So sine of 0 is 0. So it's 0 minus 0. So y is equal to 0. So my coordinate is 0, 0. And my slope is 3. So this really doesn't make too much sense for point slope form, because you do y minus 0 is equal to 3 times x minus 0. So truly, it's just y equals 3x. That's your equation of the tangent line. Okay. 25. So we're going to do g prime of x equals secant squared of x. And then you're going to say g prime of pi over 4. So we're basically doing secant of pi over 4 squared. Remember, that's what that means. You don't square the actual pi over 4. You square that value after you take the secant of it. And if you remember, with secant of pi over 4, first of all, it's in the first quadrant. And that is going to be secant of pi over 4 is the reciprocal of root 2 over 2. If you guys remember, because secant goes with cosine. Cosine of pi over 4 is root 2 over 2. So it's reciprocal of that, which is just root 2. So that's equal to root 2. And then, of course, you square it, and you get 2. Okay, so that's your slope. And let's figure out our x is pi over 4. So our y value is going to be tangent of pi over 4. Well, tangent of any one of those pi over 4s, right, 45 degrees, is 1. So our point is pi over 4, comma 1. So my equation is y minus 1 is equal to slope, which is 2 times x minus pi over 4. Okay, not too bad. And last problem here. Okay, it says determine the point or points at which the following function has a horizontal tangent. What does that mean, horizontal tangent? Well, it means the slope is 0. It's pretty easy. So what do? You set f prime of x equal to 0. Well, we got to find f prime of x first. So we're going to use the quotient rule. Bottom times derivative of the top minus the top times derivative of the bottom, which is just 1, all over the bottom squared. So let's simplify this a little bit. We get 2x squared minus 2x minus x squared all over x minus 1 squared. Okay, and so if I simplify that, I get x squared minus 2x over x minus 1 squared. All right, and then this is the deal. I want to know where that's equal to 0. Well, some of you guys are looking and going, oh, wow, there's a lot of stuff here. But do you guys agree? This really doesn't matter, does it? That denominator doesn't matter because it can't be 0 anyway. So that doesn't even have any bearing on the problem at all, because with 0, it's undefined. It's not 0. You can't. That value can't be 0. Okay. It's only the top that we're going to set equal to 0. So if I just do that, I can factor out an x. So x minus 2, that equals 0. And so I get x equals 0 and x equals 2. So that would be 0 if x is 0 or 2. And so we have two different answers, right? So when it's when it's equal to 0, we need to plug in these values now into the original problem to find out the y values. So f of 0 is equal to 0 squared over 0 minus 1, which is 0. And f of 2 is equal to 2 squared over 2 minus 1, which is 4, over 1, which is 4. And it says determine the point. So I'm looking for points, so well, we have it. 0, 0, and 2, 4. That is the answer to that problem, math fans. Okay, so that is worksheet 2. Hopefully you guys do well on this. Again, it's a lot of algebra, a lot of being careful with arithmetic, and you'll be successful with it. All right, that's it, math fans. Adios. Goodbye.